welcome to my talk, everyone. These are my details and some of my background. But before I begin, I just have to say thank you to Pamela Hill. I did a talk before this with her about coroutines with Rx Java, and a lot of this that I'm about to speak about came out of the discussions we had around that and the presentation we did, which you can find on YouTube and on my website. I think I link it there. Okay. I don't have a lot of time, so I might talk very quickly. Corner me afterwards to make sure you understand if you have any questions. Okay, let's begin. Reactive programming. Okay, actually, so reactive programming is a really big deal for me. And there's a lot of complicated things around it that are very difficult to explain. To simplify it, I can only say that reactive programming comes down to the fact that you have data that you are subscribing to or listening to or observing, things that instead of saying, oh, what's the current value, give me the current value that you have right now, you instead say, give me the current value and any future values that you might have. You're listening to changes. And the reason you want to do this is because you want your UI to be more reactive. You want your entire app to be up to date to the millisecond of what is the latest data. It's a bit abstract, difficult to understand. What it comes down to is this basic concept. Observable that emits data to an observer. I'm marking them with a star, so it's like a star that, you know, it shines light. An observer, your eye, you're watching it. And it does that. That's it. That's the magic of reactive programming, which sounds a little dumb, but the problem, though, is that there's a lot of variations. All of these have subtle differences, things where they're slightly different or, you know, don't do exactly the same thing, but they all do this thing. This is the thing they have in common. They all emit data from the one to the, it's creepy, to the other. And then, that's what it basically comes down to. If I had time, I would have given this talk, because I like observables in general. But these are the three I will be talking about today, which is LiveData, which is an observable. You'll see later why. Then Rx Java, this is the big boy. This is the observable. And finally, Channel, on Kotlin coroutines. You might also see me mention Flowable, which it's equivalent-ish to observable. There's some subtle distinctions, but I might use these a little interchangeably for the purposes of this talk. Flowable as well as Flow have similar purposes. I'll get to that later. So first off, LiveData. LiveData is it's built into the Android App Compat library. So if you've started an Android project in the last year, you probably already have this in your library, in your project somewhere. It is meant to provide an up-to-date user interface. When I say user interface, I mean like that's really the scope of where you should be using LiveData. If you start to use it outside of user interface things, it gets tricky and fuzzy. And part of the reason for that is it's tied very closely to the activity and the fragment lifecycle, which helps it to prevent leaks and crashes, which is also something I'll explain a bit later. It's reliable, it's easy, it's simple, and because of that, it's good for beginners. It's good for, you know, people who don't really know reactive programming but want their app to be reactive. So back in the day, when I first started with Android, I had to display user details on a screen. And this user details would be on a server call somewhere. So you'd be logged in and then you would know, okay, what's my current email address? And I would try to hard code the URL on the activity. I get the email address and eventually the API call comes back and I show the email address to the user. So this takes a second or two depending on where you are and your line speed, and even if you're online, it's really not a good way to do it. So over time we've learned, we need to do some separation of concerns. Currently, I'm going to showcase things using a ViewModel, a repository, and some sort of API service. This is not necessarily the best architecture, but I'm going to use this specific style of doing things just to showcase the differences between all of the various observables. So now we're getting the email both from the database as well as the API service, and obviously the database will come back first, and we write it to show it to the screen. And then eventually we get the API call back, so maybe there's been a change or something. Okay, did you miss that? The email address just had to be written to the database as well as to the activity. And now you might say, okay, maybe the repository should take care of that. It gets very complicated to figure out where exactly things should go. It becomes this tricky dance of, okay, this data goes both there and there. I mean, there are slightly better ways to do it without reactive programming, but here's one way you can do it. It's exactly the same situation, but now you have a live data object on your repository. The Room database library provides that pretty much almost automatically. It's super easy to do. And you can observe the live data object straight on your activity through your ViewModel. And then you will receive the old email address, the email address that you have in your database immediately. Or when I say immediately, I actually mean asynchronously after a millisecond or so, depending on how long your database call back takes. And then you say update email. Now, before I said get email, now I'm saying update email. Why is that a change? Well, the reason for that is we don't actually have to handle the new email address from the API service in the ViewModel at all. If we want, and again, this is not necessarily the best architecture, but if we want, we can do this, directly write to the database, and because that live data object is there, because it is being observed by the activity or the fragment, it will automatically notify the activity, oh, here's a new email address. And then it updates automatically from there. So what does the activity or the fragment we're in, what does that actually look like? How do we observe? So we're going to be on Create most of the time. If you're an Android developer, you probably know this already. And how do we access or observe our live data object? So we got our ViewModel, which I assume you have access to, and on there is a live email object. And we observe it with the observe call. We pass in this, and we create an observer object which decides what to do with the email address that we're getting once we do get it. In our case, we're going to just update the user interface. We're passing the email address. But you might ask, okay, what is this? Does it have to be an activity? This is a lifecycle owner, which is an interface that is implemented by activity and fragment. You can, if you want, implement your own lifecycle owner. Don't. Just follow the activity or the fragment lifecycle. But there's one kind of small problem here, which is that email, that's a string, which we define like this. So this is the object that we're observing right now, live data. So we're defining a string here, and if you're used to Kotlin, you would think, okay, there's no question mark there, which means it's not nullable. So this should never be null, and unfortunately that's not true. With live data, it's always nullable, and what that means depends a lot on the thing you're working with. Sometimes things emit null because it's an error, sometimes they emit null because they don't have a value yet. It gets a bit tricky, and I don't really like that. So what a lot of people actually do is they say observe non-null. It's just a little extension function to say ignore null values. But then you're kind of hiding potential issues. Not the best, but generally very workable. And this is really all you need to know how to observe a value in live data, because it's a very simple thing. You observe it, you get the changes, that's it. So now we know how to observe. So how do we manage the data that we are observing? So in our ViewModel, we are kind of cheating a little bit. We're just using the Room database. If you use the Room database, which is very nice, it automatically provides you with a live data object that you can use, and then you can observe that, and it will give you the latest database value. And then anytime the database changes, it will give you the new value as well. So you always have up-to-date values on your observer. But this is assuming you're interfacing with the library or something, not if you want to manage the data yourself. So now, mutable live data. You may have seen Rebecca do this in her presentation. Mutable live data is exactly the same as live data, except you can send it a new value and it will update that value and it will propagate. How do we update it? Fairly easily. We say post value. You can also access the value directly, but post value has the added benefit of automatically making sure that whatever observer is observing that thing will receive the value on the user interface thread. So LiveData does a tiny bit of threading, and it's just for the user interface. What's next? The other thing that LiveData does is you can check what is the last value that was emitted. Now, if you're not used to reactive programming, you might think, okay, this is normal. Just give me the value that I assigned to you last time. This is normal. But with observables, that's actually not necessarily true. The live data, they assume you're not quite used to reactive programming yet. One small problem, though. Okay, I have to skip over this quickly, but the problem here is any class outside of the user view model can now access that live email and post values to it. This is not good information hiding. You want to make this private. But if you're making it private, then you can't observe it. So how do you handle that? And that's a common problem with observables. You say the live email with the underscore in the front, because it's private, it's mutable. You can post values to it. But the one that you're observing from the outside, from your activity or your fragment, that is just a live data object that is cast from your mutable live data to a live data. So it's no longer mutable. Kind of simple-ish. And that's pretty much it. Now you can, with this code and this example, you can get the value from your repository or the view model, and you can, anytime there is any sort of update, it will automatically propagate. However, there's the additional problem. What if you close the screen? Then you need to do garbage collection, memory cleanup, make sure the life cycle ends properly. And then we have on destroy, subtle change there at the top of activity. So now you need to destroy things, and actually no, with the live data you don't have to really think about it. It kind of happens automatically because you have to pass in the lifecycle owner, which is the activity. It kind of cleans up automatically in on destroy, which automatically notifies the room database or whatever you're using that, hey, nothing is observing anymore. This is the end of the lifecycle. You can clean up. Because otherwise, maybe the database would keep a transaction open. It could cause leaks or issues. It needs to know when the observation has stopped. And this LiveData does this automatically, which is very nice. And then you clean up as before, and the activity cleans up, and those two maybe hang around for a little bit longer. Whew. Okay, next. Rx Java Observable. First a break. So I wanted to make this talk StarCraft themed. Realized it's not really going to work. And I ran out of time. So, Rx Java. It is difficult to understand at first. It really is a problem. But the moment you get used to it, it is a massive library. It's got this super long history. It just can do so much. It is powerful. It can literally adapt to any situation. It is so awesome. And it's difficult for me to convey in any single presentation just how amazing Rx Java is. But because of the limitations of time, I'm applying it to the one scenario we're doing right now, which is just the same one as before, assuming that this is the flow of data you want. Not necessarily the best one, but assuming you're using this. Now we can observe, actually now we're observing from the view model, not from the activity. So why we do this? Because before we were tied to the life cycle of the activity. You have to pass in an activity reference. And if you want to observe from the view model with live data, you have to pass an activity reference to your view model, and then things get messy. Whereas with RxJava, you can observe from anywhere. It doesn't really matter, as long as you clean up yourself afterwards. So what's going to happen here is we are getting the email address from the database to the view model. And now think of Rebecca's talk where she described MVI, where you have a single state. Because in the real world, you don't have just one email address that you're observing or just one database field and nothing else. You have various states of data that you're handling. So then you have a state, like the one Rebecca described, and then the view model decides how that state should be updated. And this state can be observed from the activity of the fragment, and then based on the state, the view, UI updates. So that's pretty nice. And then how would it happen if we update the email address? This is exactly the same as live data. Actually not. Because with RxJava, you can make API calls into observables as well. In fact, if you're using RxJava, any sort of asynchronous operation, it's probably better to use RxJava there. But again, we don't have time. Just know that you can make anything into an RxJava observable. So you get the new email address, and then you write it to the database, and then things update automatically as before. You don't have to write new logic just for when the new data comes in. Just again, this is reactive programming when it works nicely. So how do we observe in RxJava? In our activity, again in the onCreate. Actually, like I said, with RxJava, you can observe from literally any class, maybe in the initialization or wherever you want. There's no real limitations, but you have to make sure to clean up the observable yourself, regardless of what class you're in. But for now, let's stick to activity, fragment, then the onCreate. So we're accessing our state now, not an email, but we're observing the state, and we're subscribing to it. And when we get that state, we update the user interface. So thus far, this actually looks almost exactly the same as live data, just a slight wording change, a few letters different. But so this is, if you just take the basics, then there's no change. But then things get better. First off, you have error catching. I like to call this like semi-automatic error catching, because you have to write these out yourself manually. But once you do have that written out, it starts to become a habit very easily, because any error anywhere in that chain gets caught. So if that observable gets an error, it gets caught and logged. If the update UI function or the subscribe function or the state, anywhere in that there's an error, it will get caught in there. It's like a massive try-catch. It's just not always the best thing, but because you've scoped it to a specific function, it's a sensible try-catch. That being said, then there's the additional thing where you have all these operators. So let's say, for example, you're observing a state, and you have three data objects that come in and update the state, like 1, 2, 3 in short bursts, because you're accessing 3 different things. So maybe the state updates 3 times in very quick succession. And then what you'll see on the screen is every time the state updates, there's a slight flicker on the screen as things update or change or whatever. And maybe you don't want that. So what you can do is you can use operators in RxJava. This is one example. Throttle loss. All this will do is it'll make sure no update happens faster than once every 100 milliseconds. And it will take the last thing that was updated. This has maybe some issue. Maybe it's not the best one. Maybe another one you can use is distinct until change, which means if the same value is emitted twice, that observable that we're observing, it's sending you, this is my email address, and then it gets a new email address, but it's unchanged, and it says, oh, here's the same email address again. It will get ignored. And then that update UI function will never get hit, because it's saying, oh, I'm filtering it out, don't worry about it. And there are thousands of these operators. There are so many ways to control the flow of data to make sure that you get exactly the data you want and exactly the shape you want. You can also map it into different forms and so forth. But, okay, assuming you're not using any operators, there's still one problem here, which is how long will this thing observe? And it will observe forever. Well, until the garbage collector forcibly cleans it up, but you don't want that. Or you run out of memory. So how do we make sure that it stops observing when we want it to stop observing? Fairly simply, at the top of the class, you've got the thing called disposables, which is a composite disposable. What is a disposable? This disposable is simply a subscription that you can cancel. And we add the existing subscription we have to that disposable, and then in the onDestroy, in this case, we can say disposables.clear. But you can have multiple life cycles. You can say, these are disposables I all add in onResume, and we all cancel them in onPause, or these are the ones that I have in onCreate and cancel in onDestroy. And all this does, it just says to stop observing. So now that we know how to observe, how do we do the actual observer and management of data to send the data to the observer? So inside the ViewModel, let's say you have an observable email that you're observing directly. You can use the Room database library again. It really is useful. The Room database library has Rx Java support, and it exposes a flowable, which it also exposes an observable. You can determine what you want from the database, but again, there's subtle differences I don't have a lot of time to go into. But it doesn't make that much of a difference in how you observe it. You still subscribe to a flowable as the same way as you would subscribe to an observable. But if you want to manage the data yourself, this is something you can do. Publish subject is a type of observable, and you are passing in the generic function state there, because you have a state object that contains an email address or whatever. And ironically, the publish object is not necessarily the best class to use here. Some of the Rx Java experienced people might say, maybe you shouldn't use publish subject. And I'm doing this on purpose to just explain that Rx Java has hundreds of classes like publish subject and behavior relay and relay subject and just straight observable, and all of these are slight variations. And it takes a lot of thinking and research to make sure that you have exactly the right class, exactly the right observable, which is a slight negative and a positive, depending on what your situation is. But in our case, publish subject, it emits data, it sends out data, and if nothing is listening, that data is lost. But let's assume we're accepting that. How do we send the data? We just say on next. So in our case, we get the email address, we've got state observable.onNext, and we send it a state with the email. Now in the real world, you would have various fields in that state, but sticking to email for now. And then we still have the same information hiding error as we had before, or not error, danger, which is we want to make it private, and then expose for the publicly an observable that you can't post to, and you just use the hide function. And if you just say hide on any observable, then that means no one can post values to it. You can expose it publicly, don't worry. So you can observe it, but you can't send data to it. And this is all part of what Rebecca earlier said, unidirectional data flow. You want all your data to come from one point and everything to watch it from another point. So now you know how to do that, and then there's a cleanup. Oh well. So the animation, like I said, everything should happen fairly automatically from there, and then your state updates every time there's a change in the database. But then in the onStop or the onDestroy, or depending on what lifecycle you personally define, you have to manually clean up those disposables yourself. And then not only in the activity, you also have to say in the activity, oh, well, the ViewModel, I have to make sure the ViewModel has a lifecycle itself. Anything that uses Rx Java, you need to be aware of the lifecycle so that you can say disposables.clear, and then now ViewModel is informed that it needs to clean up, and then you run the clean function or the clear function or whatever you're using. And this informs the repository, the Room database, that your observable is no longer being observed. You can clean up, everything is fine now. And then the memory cleanup should happen more or less as before. So, channel and flow. They are experimental. As Pamela explained, the classes themselves are stable, but a lot of the internal functions are experimental. And I found it's mostly fine to use experimental functions, not in production necessarily, but that's not true. 5 more minutes than that. The thing though is that there's an amazing community. The channel and flow and everything is just like, there's so many discussions around it because everyone is building this class and the coroutines library. They care a lot about code readability and about you as developer, which results in a very readable code, which is great. That being said, though, coroutines channel and flow is just one small part of the coroutines library. Coroutines library has a main function, which is asynchronous operations. Channel and flow is part of that, but that's not necessarily the main function of the coroutine library. Whereas with Rx Java, that is the main function. So you have a smaller priority among the developers for what is important. So if you're working with channel and flow, just know you're second in line between other functions. But that being said, it's the future. It is the most elegant solution in my mind. Coroutines is the best. Or should I say, all the best. So here we have the same thing as before, and actually it's pretty much identical to Rx Java, because a lot of the same people that used Rx Java develop coroutines, and so things will happen exactly the same as before. We're still updating the okay, that's actually the first difference. Instead of using an observable, you're using a suspending operation for things like API calls. There's no reason to turn it into an observable and wait for the result and process to subscribe. What actually is happening behind the scenes is that suspending function is an observable, just doesn't look like it. It's like in the bytecode, but from what you're seeing, when you're calling a suspending function, it just looks like normal imperative programming, even though it secretly is an observable. So you still get the new email address, and if you update the database, it automatically updates as before. So how do we observe? Well, first off, we have to have a scope of some kind. I found this to be the easiest, not necessarily the best, but then that means we can launch a coroutine, like so. And we said on main scope, so this will launch automatically on the main thread. And then we have a user ViewModel.stateFlow. So this is the state object that we are observing, and we are collecting the values in that object, and every time there's a new value, it will update the UI with the new state. And then this is a looping function, so it will go back to collect and suspend there and stop there forever until there's a new state or until this operation is cancelled. So if you write any code below there, that code will never get reached because this flow will emit forever or until the coroutine is cancelled. I mean, it depends on the flow. Some flows emit only one object or two. Other flows are kind of open to emit as long as needed. But you have to clean up the coroutines at the end. Just say cancel children. So all of the coroutines launched by this class using the launch function will be cancelled and cleaned up, and the observables will not be observed anymore, and there's no memory leaks. But just changed. No. Okay, so maybe you want operators like in Rx Java. The throttle last operator does not exist in coroutines as of last week, but there is a PR to put it in because it's literally exactly the same. And the same with debounce, that's in Rx Java, or distinct until changed. All of the Rx Java operators that people like to use in Rx Java, actually most of the popular ones are already in coroutines. Some of them are experimental, some of them have PRs but haven't gone in yet. People want it to be the same as Rx Java. So if you like Rx Java, it's going to be the same but better. So otherwise things are very similar. Now you know how to observe. How do you handle observable? We have a flow object, room database, same as before. The room has coroutine support, and you can get a flow, which is nice. And I suggest you use it. But assuming you have to handle the data yourself, you would use a channel. Well, it depends on what you're emitting. But in our case, if you have data that might change at any moment for an indeterminate amount of time, you want to use channel. And this is more or less the same as published subject, which I described before. It's broadcasting stuff out to whatever might be listening. And if nothing is listening, that value gets lost. Well, except passing a value of 1 in, so it's got a capacity of 1, which means it will hold on to that value for a little bit and wait for something to collect it out. So the value, actually the value does not get lost. It does retain state, kind of. But how do we send a value to it, to update it? We can say offer. Now, offer is exactly what it sounds like. You're offering a value. Here's the state. I've got the email, I'm building a state object. Here's the state, you can take it or leave it. And it does it. It returns true if it takes it. It false if it's full, if it's at capacity, because we find capacity at the top. And it throws an exception. Why did I write that? It throws an exception if if it's full, if it's been cancelled, which is also something I've done before. But what if you want to force it to accept it? Make sure that it accepts it, even if you have to wait. Well, you just have to launch a coroutine, and then instead of saying offer, you say send, and when you send it, it waits, and it says, oh, you're at capacity. I'll wait for you to open up, and then I'll send you the value. And then you can queue these up. You can update state 1,000,000 times, and those values will be queued up, so it handles back pressure until everything is done. But that being said, we still have offer. You hide it as a flow. Okay, I'm running out of time. So channels are the inside, flows are on the outside, because this is difficult to get. But channels are for communication between coroutines inside of a class, data management. Flows are for observing from the outside. So if you're in an activity and you're accessing a view model and you want to observe something, it will always be a flow. If it's a channel, that's a mistake. Okay, so now we know how to do that in code. And then the cleanup, well, like I said, these things still happen exactly the same. I'm very proud of my animation, so I made them happen too many times. But now we're in onDestroy. How do we do that? Well, remember we cancel the coroutine, so all of the observers, all of the things that are observing gets cancelled automatically. And in our view model, if we're observing things, we have to also say, oh, cancel your coroutines, because the view model has its own scope that is separate from the activity scope. And then the cleanup happens more or less as before. So finally, comparisons. Okay, live data. It's easy to read. The lifecycle is full of automatic. So if you're nervous about memory leaks, if you're a new programmer or you're in a rush, live data is great. It's always nullable, which I don't like, but some people might. The scope, use it for the user interface. If you're using the live data outside of the user interface, the further you stray from the UI, the more you're going to run into issues. And it saves a lot of value. So even if you're not used to reactive programming, and it's a good middle ground. And the threading, like I said, user interface only. It's stable, it's reliable. There's a few good the documentation and the official stuff out there is pretty good, and it doesn't have multi-platform support. If you want that, maybe go to the room next door. So Rx Java, it's not easy to read, and you have to do a lot of the stuff completely yourself. You have to configure whether or not you want a nullable return or not. There's a lot of things that you can use it anywhere. The scope is anywhere, which is great. But any kind of change you want, you'd have to configure it yourself, and it takes just so much time and effort to make sure you're using exactly the right thing, and you will make mistakes. But if you've got it working right, it's amazing. And the threading is easy. I didn't have time, but it's super easy to do. It's a single line to just change a thread, and it's stable and reliable. The guides and the documentations are not that good, which is actually, there are really good guides out there for Rx Java, but it's hard to find them. And it's hard to know whether or not you're reading a good guide or not, unless you don't need that guide, which is sad. And when I say it's got multi-platform support, it doesn't, you can't build a Kotlin native project with RxJava, but a lot of the libraries and the tools that you're using very easily convert something from a Kotlin native to a RxJava. So you can subscribe to multi-platform projects with RxJava, which is nice. Finally, coroutines, it's mostly easy to read. Just some caveats with cancellation and stuff. The lifecycle cleanup is semi-automatic, bit better than RxJava. Nullability is just the best. The IDE enforces it. Everything that Kotlin did to Java, that's what coroutines does to RxJava. It's more or less the same, but nicer. But all that being said, threading is like super great. It's not super stable yet. Mostly stable. And I mean, coroutine library is written in Kotlin native. So you can completely write a Kotlin multi-platform project with the coroutine library, which is great, except that multi-platform projects don't really support threading. so that's a problem. But if you sum this all up, what are my feelings about it? And that's pretty much how I feel. LiveData should be used by beginners, or anyone, more than anyone should use LiveData, like plus. And I like it. And if you're working on a small project or on a new project, or you are yourself new to Android development, LiveData is definitely the best choice. RxJava for a bit larger teams, more supportive teams that work closely together and can teach each other, and you have at least one expert in RxJava close by because you will need help. Then RxJava is definitely the best. And coroutine should be used by everyone who is willing to accept the risk of cutting edge. It's almost there. It's not quite there, but it's almost there when it comes to things like I said, that one function which has a PR open that I might want to use, but it's not quite in yet. But if you're willing to wait just a little bit, coroutines is the best.
Yeah, we're close to